Okay, so there were 3 questions that were asked on worksheet 2 and 3. The first one was how come number 9 is no solution? Now when we consider a cosecant graph, we know that for cosecant, the input for a cosecant inverse is a ratio, and this ratio must be greater than 1. Now some people would say, well, how do I know what this fraction is? How do I know if this fraction is greater than 1? Well, when I look at this, while I may not know the exact decimal for square root 2, I know that it is smaller than 2. And the way that I know that is because square root 4 is equal to 2. So right now, this is essentially the problem that I have been given. And when I look at this problem here, I can then see that the ratio that is the input for cosecant inverse is invalid. Therefore, this is a no solution. In question 21, we need to go ahead and solve this quadratic. Now, there are a couple strategies that we could go through. Some people might think of squaring both sides because sine and cosine are connected with the Pythagorean identity. The reason why I would not recommend that here is because even if I did square both sides, I would then be left with the sine to the 4th power, and that is not going to allow me to do a replacement. Instead, if we go ahead and take a look at this part right here, the sine squared theta, and ask ourselves, how can I replace that with something involving cosine? And recall our identity, sine squared theta plus cosine squared theta equals 1. So that being said, we know that sine squared theta is equal to 1 minus cosine squared theta. So I'm going to take this entire part and plug it in right there. Okay, so what that will look like for us is that will give us, let me switch colors, 2 quantity 1 minus cosine squared theta minus cosine theta minus 1 equals 0. And after I distribute, and I will have 2 minus 2 cosine squared theta minus cosine theta minus 1 equals 0. And at this point, I would move everything to the other side so that I have a positive squared variable. We can combine the 2 and the 1. So if I go ahead and do that, I will have 2 cosine squared theta positive plus cosine theta, and then I would have a minus 1 equaling to 0. And then now what I want to do is I want to go ahead and I want to factor this. So when I go to factor this, I'm going to have 2 cosine theta, and I'm going to have cosine theta, and I know that I'm going to have a 1 and a 1, and the question is, where do I need the minus? Well, since I want to have a positive cosine, the one that multiplies with the 2 must be a plus, and then this must be a minus. And now that I've gotten to here, I can set each of these parentheses equal to 0. So I end up getting that 2 cosine theta minus 1 equals 0. Therefore, cosine theta equals positive 1/2. And over here, I have cosine theta plus 1 equals 0, or cosine theta equals negative 1. And when I go ahead and solve both of those, for this first one, I'm going to have answers in quadrants 1 and 4. And I don't recall if we were supposed to be in radians or degrees because I cut that part of the problem off. But let's just say that we were supposed to be in radians. That would be pi thirds and 5 pi thirds. And then over here, this would be at pi. If our angles were supposed to be in degrees, that would be 60, 300, and 180. All right, for the last problem, we were looking on worksheet 3. So the first 2 are from worksheet 2, and this last one is from worksheet 3. Okay, in this problem here, we have a 4th power of secant of 2x. So what we first want to do is we want to go ahead and square root this. So if I square root this, I'm going to have secant squared of 2x equals plus or minus 2. So I'm essentially thinking of 2 different scenarios. Secant squared of 2x equals positive 2, secant squared of 2x equals negative 2. Now we know that it's impossible to have a quantity squared that equals a negative number. Therefore, when I square root this again, I don't even have to worry about that negative sign because that's not a real solution. So then after I square root again, I get secant of 2x equals plus or minus square root 2. Now because this is a 2x problem, that means I need to double my interval. All right, so normally I had that x was in 0 to 2 pi. However, since I have 2x, that means 2x is going to be in 0 to 4 pi. And because I have plus or minus root 2, that's essentially saying all of the reference angles where secant would equal positive root 2 or negative root 2. And that would be all of my reference angles with a reference angle of pi fourths. So I start off by saying that 2x is equal to, we're going to have pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths, and that's the first time around the circle. Now because my interval goes to 4 pi, I have to go around the circle again. So to go around the circle again, I'm going to add the equivalent of 2 pi to each of those answers. So I'm adding 8 fourths to each of them, giving me 9 pi fourths, 11 pi fourths, 13 pi fourths, and then lastly 15 pi fourths. And those are all the answers that are equal to 2x. However, I want my answer for just x. So I need to take all of these answers and multiply them by a half. And that's how I get the final solution set of pi eighths, 3 pi eighths, 5 pi eighths, 7 pi eighths, and then essentially all of these are going to continue just being over an eighths instead of a fourth like they were before. All right, that is it, and good luck on the rest of your test prep.